So module 2, there are two chapters. One is heat and work and heat. So what is work and heat? Thermodynamic definition of work and heat. Then units, sign convention, problems. These are all the things that are included in module 2. Other chapter is the first law of thermodynamics. That is in this chapter that we'll see later. Let's look at the work and the heat. Okay. So what is work? Right? Work and heat. What is work and what is heat? So what is work? What is heat? Can anybody define? Yes. Okay. Am I audible? Yeah, please. Who is that? No, fine. So let's look at the definition of work and heat. So what is work and what is heat? So first of all, if you see, we have seen the concept of the system and surrounding that we already discussed. So a closed system and its surrounding can interact in two ways. There are two ways of interactions possible. One is by work transfer and the other one is by heat transfer. When I say interact, energy interaction. Okay, when we look at the interaction of work surrounding in a system, right? So what is system? System is a region of interest on which I am doing a energy study, right? So what is the interaction? How energy can interact, right? Thermodynamics is about all about energy, we have said. So what is that? How is it energy interaction between a system and surrounding is possible? So there are two ways. One is a work transfer, other one is called a heat transfer. So these are the two ways that energy can be transferred from a system to surrounding or surrounding to system. So what happens if you add work to the system or remove work from the system or you add heat from the system or remove heat from the system? So it causes changes, right? What it causes? It causes if you add heat to the system, the pressure, volume, temperature will increase. Okay, the properties of the system, value of properties of the system will increase. Similarly, if you add work, then also the properties will increase. Whether I add heat or work, both of them cause same changes, right? Both work and the heat can produce similar results. Whatever you can achieve by heat transfer, you can achieve as well by the work transfer. So like that, both them cause an increase in addition of work or heat causes an increase in properties of the system. And these are called energy interactions. Both the work and the heat are called energy interactions and bring about same changes in the properties of the system. So both the work and heat can bring the same changes in the property. So thermodynamics mainly studies these interactions and the associated property changes of the system. Right? That's what we said. Thermodynamics is basically study of these energy interaction and what are the property changes. Whenever there is energy interaction, there is a property change. So this energy has played an important role in our life. Energy, any invention, any discovery related to energy has brought a lot of changes in human life. So if you see the in the books you might have read, the prehistoric people, humans, what they used to do, they used to eat raw food, right? Very olden days. No? There was not much difference between animals and the humans. Okay, so animals. Have you seen any animal eating a cooked food? Has anyone seen an animal eating cooked food, boiled food? Yes. Can you hear me? Am I audible to you?
Yes, sir.
Okay. So have you seen any animal eating a cooked food?
Yeah.
Huh? No, I mean, sorry. If you cook, humans cook and give their food to animals, that is fine. Not domestic animals I'm talking. Suppose you take wild animals in natural way. Naturally, animals, they don't cook food, right? Do they cook food? Boil food
No.
and eat? No, right? So all animals eat raw food, whatever is available naturally, right? Whereas humans, we don't eat. Sometimes we do eat raw food, like fruits. We eat them raw, but usually we process it. Right? Very often, one of the processing method is the boiling, cooking the food. One of the processing food way to process food is boiling or cooking the food. Okay, so we usually cook food, right? Boil it and then we eat, right? So this happened. You must have already studied in schools and why humans started eating cooked food. Why other animals don't eat? Somewhere in schools, some teachers might have told you that humans accidentally discovered the that cooked food is a tasty one, good one, right? Accidental fire was there. You know how it happened is maybe there's theories. People have proposed theories why humans started eating a cooked food. So accidentally during the forest fire, so whenever there is an accidental fire, so they found that some animals got caught and they died and they were burned. So when they burn the flesh of those such animals, when humans consume, they found that it is much better compared to a raw food, right? Raw meat. So therefore, what happened after that? Humans started. One is he found that here is that the cooked food is much better than the raw food. And then he discovered that there is something called fire and the art of mastering the fire. Right? This fire was there. Right? It used to occur accidentally, but humans started to create it. Right? Humans started to create the fire and use it for their advantage. This was an important discovery in human life. Right? The usage of fire. Right? Was the important discovery in the human life. Other one was use of weapons, right? Using the stone to kill the animals, making the small sharp weapons out of stone or metal pieces or the dead animal bones. So this was the second. This was the first invention. Later it was the invention of fire, and that too using the fire, not just existing fire, creating fire and then using it. Even if fire is not there, you like create fire, use it for your day-to-day activities. This was a very great invention by human beings. Okay, you have seen what no other animal has mastered this. See, humans are also one animal. Right? We are also one species. There are so many species are there in the earth. Right? Different types of animals are there. Right? No? Animals which can fly, animals which can swim, which live in water, which live on earth surface. Right? So like that, the different types are there. Billions of millions of type of species are there. Microbes are there. Right? Big, small. Right? But none of them have been able to use the fire. The only human is the only species who is able to create fire and use it. Okay, no other animal. This is how we are. This is the first distinction between. That is how we started departing from the other rest of the animals on Earth. Okay, otherwise we were also like any other animal. Man was also an animal. He was just uh, living there. But first difference was usage of weapons, right? Making weapons, So usually, if we see any the animal, they use their own natural what God has given to them to fetch food, right? Okay, they don't create their weapons. No animal creates its own weapon, but human is able to create weapons and use them to hunt the animals and get food to get food. Right? He was able to prepare weapons and use them. So no other animal makes weapons. Whatever God has given naturally, that only it makes use for getting food, right, or for living. But human was able to create weapons, use them, and then next invention is the usage of fire. See, fire means heat. Fire gives you a lot of high temperature. So the use of this high temperature was the greatest invention. Then there are so many inventions are there in life. So we see like the use of wheel, right? Transport, how to transport goods, material from one place to other place. No other animal uses a wheel to transport any goods, but we humans use a wheels to transport a mass. What other animals do? They lift with their muscles. They lift any mass with their muscle and keep transport it. But we humans make use of wheel to transport it so that we can easily transport. So that is the biggest invention. Okay, and when it comes to work or doing work, ease of doing work, right? We started using the wheels, machines, mechanisms, right? So this is what led to the difference between the other animals and us. To heat was used to get a better food or better living conditions. That matter. Heat is not only used to cook food; heat is used for all other purposes, like for living a comfortable life. You want to take bath, you take a bath in hot water, but animals don't do it, right? If they want to take they want to dip in water, they go and dip in naturally cold water. We are not like that. We make use of the hot water like that. So not only just for eating food, even for comfortable living, you must use heat, right? Similarly, work is another form of energy. See, there are a lot of inventions that have happened regarding work. So for the very basic, the invention was first one was the weapons, making use of weapons. So that you want to do work, you want to kill animal or get food for the. So for that, people use, or you want to cut a tree, okay, or pluck food from that tree. So humans designed weapons for that, or instruments, in other words. So this making doing work in a better way by using weapons, mechanisms, and the wheels to transport. Again, transport is another way of doing work or move around. Transport was not just moving the goods, even to move around, right? So if you see, that was a very basic kind of invention, and they're all great inventions. Okay, see, that has changed the way the humans live. Every energy invention, any invention related to energy, if you look at that, it has brought a huge change in the human life. Great change. Things never went back to what they used to be earlier, right? When humans invented that they can use fire, they stopped eating raw food. That's it, right? Almost. Very rarely we eat raw food, right? Once we started realize that I can use fire and cook food, we stopped eating that. So it changed the life, the way we live. That was changed by the invention. Any invention, any discovery related to heat and energy, heat, energy, work, whatever. Any invention related to energy has brought a huge change in human life. So like that, as I said, when you started using mechanisms or when you started using wheels to transport, once humans learned that you can transport easily mass using a wheel, it changed everything, right? Okay, the way they lived, right? Okay, then there is a then if you see in the history, very big changes in the energy. So a lot of changes happened. A lot of mechanisms developed, right? Humans, although they could not swim much, right? But they built ships, started navigating. Transport sector was totally revolutionized with such inventions, by building boats, by sailing in a river or in a sea, moving around, or any invention related to warfare, weapons design, or therefore there were the better invention of this gunpowder, the bombs, right? Guns, they all changed. They changed the way we lived, right? If you see History Channel, they say that olden days, very old days, when these guns were not there, the cannons were not there. Those days, people built very high-rise forts so as they can protect from their enemies. But once the cannons were found, bombs were found, they would easily blast through those high-rise walls. Forts then became short but thick so that they can withstand the impact of the bomb, the cannon fire, right? So like that, it changed. It changed the way we live. People stopped building large buildings, large fort. They started building small fort. So it changed. Any invention related to energy has brought huge change in the way we live. Okay. So then the biggest invention of all this is, if you look at the olden days, work, to do work, right? To move things, to make things, to prepare things, work, whatever you do, work, right? To transport things, to fabricate items. Work was done basically using a human muscle or an animal muscle. Okay, most of the time it was very exception. Few exceptions are there. Like people do use some amount of naturally existing work, that is the kinetic energy of the wind was used to navigate in ship, right? Kinetic energy, wind was used to navigate. The other way, windmills were there olden days. Windmills, wind kinetic energy was used to mill the grains, to get powder out of these different grains. Windmills were those days, or mills were based on even a flowing current of water, right? So that was naturally occurring work was available. To some extent, they harvest it and try to use in day-to-day life, but not predominantly. Predominantly, work was done by muscle power, right? Any work you have to do, either you have to do, humans have to do with their own muscle, or use any other animal, like any elephant, horse, different ass, whatever it is, donkeys, different animals were used depending on the geography, depending on whatever animal is available in that region. Like if you go to deserts, they use camel, right? So depending on whatever is available, animals, they domesticated these animals, use them to do the work, right? Suppose you want to guard something. To guard something, they use dogs, right? Dogs were domesticated. Right? So like that, to till the land for farming activities, bullocks were used, right? So like that, different animal to do any work, the animal, either human being depended on the animal muscle or the human muscle. But this changed. Everything got changed. Life never went back. Never, life was never the way it used to be. Once the human being invented the biggest invention, that is that you can do work by non-living things. Okay, this was the biggest invention. So if that led to the industrial revolution, okay, so that led to the industrial revolution when this engine was developed, steam engines. First time, people realized that you can do work using non-living things by burning coal, right? By burning coal, generate heat, use the heat to generate steam, and that steam is used to drive the turbine, the steam engine. So this steam engine was basically doing work using a non-living thing. Engine is not non-living, right? It's not a living entity. It's not an animal or human. Nothing it is. It's a non-living thing, but it could do work. That was the biggest discovery in life, biggest invention in human history. That changed everything. So in history, you might have studied schools. There is something called an industrial revolution era. After the industrial revolution changed, how the life changed, colonization, mass production of goods. These European countries just went around the world, colonized the different countries. They were looking for the markets because they were producing goods in huge quantities. So they wanted to sell them. They needed buyers. So that is the era of colonization, right? European powers ruled around the world. They ruled most of the world was ruled by European countries, right? This this came from an industrial revolution because they adopted industrial revolution much faster compared to rest of the world. They were the first to invent this industrial the engines and also to use it technology. So that led to the total change in lifestyle, right? So people, you might have seen some old movies and people lived in small fortified cities, right? They be fort protected from outside. You live inside. You lock the. There will be a big gate. You close it. You live inside, right? Only whenever you want to go out of the city, use only one entrance. Go out. You want to fetch food or whatever you want to do outside, take it, come back. Then secure yourself inside the city, right? Inside a fortified city. That is how people lived, most of them, except nomads. Nomads were not living in the cities. They were just moving around. But most of the world, the civilized world, lived in fortified cities. They built a wall around themselves, right? And they lived inside. This is how they lived. But industrial revolution destroyed it. Now there is no fortified cities. Any fort is there in any city, they only become monuments, right? If you go to any city, forts are just monuments. Your nearest fort is Baker Fort, right? Kasargod is Baker Fort. I'm sure most of you might have seen that Baker Fort. Have you seen Baker Fort? Anyone has seen Baker Fort?
Yes, sir.
So similarly, if you go to this part of the country, the forts are not much. This is the Malnad and hilly region. Fort were not much here. But if you go to plains, right? You go to any other part of the country, any other districts except Konkan and Malnad. The moment you go to plains, every city has got any major city. If you go, they will have the relics and monuments, remains of the forts. You go to Bangalore. Bangalore also has got fort, small fort, right? It's there. Mysore has a fort. Any city you go, any major prominent city has a fort. That is how people lived. But once industrial revolution happened, there was no use because industrial revolution brought these aeroplanes, huge mechanized weapons. They could simply destroy any fort. So people felt it's no use. Fort can never anymore protect you, right? So its usage was lost, right? Usefulness was lost. Therefore, people stopped using those forts. So this industrial revolution led to these changes, the way we live, right? Okay, the way we all of us now live in a very concrete buildings. This is the result of industrial revolution. Concrete cement came very recently. Cement, Portland cement, what we use very popularly, it doesn't have much history, just 120 years, that's all. It did not exist before. Cement did not exist earlier. Or for that matter, this RCC, reinforcement concrete, right? That did not exist earlier. The construction technology was entirely different. There was no RCC. Okay? So all this came from the industrial revolution, mass production, right? Producing goods in one place and distributing it to all over. Because the mechanization made it easy to produce goods and transport it anyway. This is the biggest thing, advantages is brought. But earlier it was goods were produced locally, distributed. Wherever need is there, you produce that place, people will produce and use it. That's all. The trade was not for produced goods. Trade was limited to food items, something like that. Maybe, of course, some cloths were there, but not to the extent the way it is done today. Okay, so it changed everything. Any invention, any discovery related to energy has brought a huge change in our life. Okay, anything you just say, new thing when you find that anything new about energy, it brings huge change in the life. Earlier there was a steam engines. Steam engines basically led to this transport sector was dependent on these railways, right? Okay, metal tracks. Vehicle moved on a metal track. Individual automobiles were not very popular. Steam engine based automobiles were there, although, but they were not so popular like railways. Railways, the steam engine led to use of railways extensively. But when IC engines came into picture, it changed. Everything changed, right? IC engines made it easy to make individual automobiles when you go on road, right? No need to build a railway track everywhere. Railway is confined, it is restricted. It can move only on the railway, right? Train can move on only railway. That's called railway. Two gateways are there, no metal strips. That is called railway. So a train can move on only railway, right? It can't move on a normal road. It changed. When IC engines were developed, it changed everything. You don't no need to have a railway. Of course, railways are there for different purpose, but the way transport sector, it revolutionized it. Then is when these turbines were invented. Olden days, before turbines were invented, the aircrafts were based on IC engines, right? There were using the IC engines. The aircraft was driven basically by IC engine. But when they found that the turbine is much more convenient way for using aircraft, they stopped using the IC engines. Now, if you take any aircraft, it never uses IC engine. There is no aircraft which flies on an IC engine. It is basically the turbines, gas turbines that drive the aerospace, this aircraft, airlines. Okay, so like that, any invention, any discovery related to energy has brought huge change in our life. It affects our life, right? So anything, electricity for that matter, it's a form of energy. When electricity invented, it changed many things, right? Many things. Can you imagine life without electricity? Just imagine if there is no electricity, what will be the life? For a moment, just 2 minutes spend, just close your eyes and think about what will be the life if there is no electricity, right? If there is no electricity, you and I will not be talking like this, right? We are sitting remotely, but still we are communicating, right? This is because of not just because of electricity, but without electricity, of course, it is not possible, right? Electricity, there are other things which you need, communication devices, but all these communication devices, they are working basically on electrical energy, right? Without electrical energy, you can't do anything. Our life will become nothing. You will pathetic. If you just imagine, your life will be pathetic. Just morning, if there is no electricity, what will happen? Just for a moment, you imagine how the life will be if there is no electricity. So, what will be implications of absence of electricity? Can you quote few examples? Anyone of you? What will happen if there is no electricity? Some examples. What will? How it will affect our life, day-to-day life? Any response? What will happen if there is no electricity? Let us say tomorrow onwards, no electricity. Let's say I don't get any electricity. How it will affect my life? What are the problems I will face if there is no electricity? Can you give some examples?
Communication will be affected.
Yes, communication. No communication. Remote communication. We should be physically nearby. Only then we can speak to each other. Otherwise, we can't communicate. Right? Distant communication is not possible. Okay. Then, what else? Anything else? Others? Are you there, or you switched on your mobile and left? What about others? Sorry.
Yes.
Hello.
Yes, sir.
Yeah. What will happen if there is no electricity? She said that if there is no electricity, communication will not be able to communicate. Life will be difficult. Communication, no communication, distance communication. And if you are nearby, you can communicate. You can speak to each other. No, that is fine. Won't be easy. How it will affect? One example. She quoted one communication.
In health, in hospitals, the ECG machines or any machines which we use for health purpose won't work. And
okay. Health
there will be more
diagnostic.
deaths.
Okay. So health diagnostic machines that are there, X-rays, ultrasound, right? The BP, they check this BP, ECG they call it as. And then there are many instruments are there. Like for that matter, this ventilator, artificial breathing support. People have breathing problem. This corona has got many people face this breathing problem. So artificially aid that breathing, breathing aid it is called. So such equipments will not work. Your healthcare will collapse, right? Then you will be at the mercy of God, like animals, right? If you are like what animals happens, they don't take any medicine, they don't go to doctor, right? They live there. Anything health problem happens, they face it or they die out of that health problems. But we humans are able to do this because we have invented so many things, not just electricity. There is healthcare system that is there, but that is dependent on electricity. That's what he says. So fine. Anybody else? Anything else other than that? Communication will be
Factories
it will be-
machines cannot be run.
Yeah, factory machines will
In
not work.
factories
Right?
machines
Yes, yes. Industries will not stop working, right? If industries stop working, what will happen? Huh? Morning
Economic
Maggie, 2 minutes. Economy will go down. That is fine.
economy
First thing,
collapse.
your economy will collapse. You will not get 2 minutes Maggie, right? Maggie noodles. Sir? 2 minutes, they say, no? That is produced in factories, right? You will not get it. The shirt you wear, the slippers you wear, will not be available. All these goods will not be available. You have to make your own slipper. You have to weave your own shirt manually. That cloth is produced in a factories. Toothpaste that you use, brush that you use, right? All this will be gone if there's no electricity, right? So these are the things that will affect our life. So energy, any invention related to energy has brought a huge change in our lifestyle. Okay, so therefore energy is very important. Quantitative study, not qualitative study. What we are talking here is only qualitative studies. I say work and data, energy forms of energy, both bring similar changes. Not just a qualitative study. That is not sufficient. You must be able to quantify what is the different forms of energy, how much it is there, how much I can use it, how much I cannot use it, how to use it, what I should do it, how I can convert it from one form to other form, how much I can convert. These are all very important. The quantitative studies are very important related to energy because they affect our day-to-day life. So if you take one example, just another example I will discuss. Let's say all of you know that electricity, I said, no? Electricity, without electricity, you cannot imagine your life. Major source of energy, if you see, even today, most of the energy is thermal power, right? You understand thermal power plant? When I say thermal power plant, do you understand the word thermal power plant? Yes or no? No response. Am I audible to you?
Yes, sir.
Okay. When I say thermal power plant, do you understand what is a thermal power plant?
Yes, sir.
Hmm? Have you heard word thermal power plant or not?
Yes, sir.
Where it is? Any example of thermal power plant nearby? Any thermal power plant is there in Mangalore, nearby Mangalore? Can anybody give example of a thermal power plant? Not necessarily nearby Bangalore. Any thermal power plant. Just give example. Name. Can anybody name thermal power plant? When I say thermal,
Raichur.
Sorry.
Raichur.
Raichur. Right? Raichur, there is a thermal power plant. KPTCL.
Yes, sir.
KPCC, sorry. Karnataka Power Corporation has got a thermal power plant in Raichur. Similarly, there is a Beldari one there is there. And there is in Mangalore also it is there. Not Mangalore, Udupi district it is there. Sorry, yeah, Udupi. What is the name of that?
Udupi Power Corporation.
Udupi Power Corporation was the old name it is. Now it is Adani Power Corporation. Okay.
Oh.
So that is a thermal power plant. In thermal power plant, what happens? You convert the chemical energy of coal. Coal is used to produce electric power. Right? Coal is brought from a faraway place. Right? This Udupi power plant, I don't know what is the capacity of it. Normally it will be in megawatts. Like 1000 megawatts, 2000 megawatts, 3000 megawatts. That is how the power plants are built. 500 megawatts, 1000 megawatts, 2000. There are big power plants. They are called ultra mega power plants. Right? Their ultra mega power plant is in Bijapur. Right? They are 4000 plus. Any mega power plant which is of the size more than 4000 megawatts is known as ultra mega power plants. Right? So these are these power plants, they produce power, right? So 1 megawatt means 1 mega. What is the meaning of mega? Do you know the mega word?
10 to the
Megabyte
power of
means
6.
10 to the power of 6, right? Megabyte, kilobyte. You have to use word, no? Kilobyte, KB. data transmission, or a capacity of the hard disk, right? How many bytes it can store. You say 2 GB, 3 GB. Nowadays it is 16 GB. Pen drive capacity is nowadays 36 GB. You know? Recent pen drives, what is the size? All of you use pen drive or not? Don't use pen drive? You know pen drive when I say? So like anyway, like that. Mega means 10 to the mega means 10 to the power 6. It is megawatt, right? Megawatt power plant, right? So similarly, there is a kilowatt. Kilo means 1000 watts. 10 to the power 6 means million. Million watt is called a megawatt. Megawatt. So like that, there will be 500 megawatt power plant or 1000 megawatt power plant. 1 watt means, what is the watt? Can anybody, you know what is watt means?
Yes, sir.
PUC physics you have studied. What is the meaning of watt? Can you give? Watt is a power, unit of power. Is there any other power, unit of power? Watt is 1.
Horsepower, HP.
Horsepower. Okay, there is a British unit. Okay. What is watt? Watt in terms of joules. Can anybody say? Joule is a form of energy. The rate of energy is called watt. Okay. In terms of joules, can you express watt? Okay, 1 watt means energy generated at the rate of 1 joule per second. If you generate energy or use energy, consume energy, you can consume energy or you can generate energy, both way, right? Power plant generates energy, we people consume energy, right? So if you see your house line, electrical line, they say 5 kV line I have 3 kV line, right? So like that. So how much watt energy you are able to consume, or how much watt energy you are able to generate. So there it is, this 1 watt means 1 joules per second. If you generate energy at the rate of 1 joules per second, that is called 1 watt. So similarly, if you say 1 kilowatt, 1 kilowatt means 1000 joules per second. Every second, 1000 joules of energy is generated or consumed. Similarly, 1 megawatt means 1 million joules per second is generated or consumed. When I say 1000 megawatt, 1000 megawatt power plant is very common. Having 1000 megawatt is very common. 1000, 2000, 3000, 4000, up to 8000 megawatt power plants are available. 10,000. Some very big power plants are 10,000 megawatt. Okay, so 1000 megawatt means 1000 million, 1000 million or a gigabytes, gigawatt sometimes they use. Nowadays gigawatt word is used, right? 1000 mega means 1 giga. So gigawatt plants are available nowadays. Okay, so so much joules per second you have to generate energy. If I have to generate so much energy, how much coal I have to burn per second, right? How do I get it? By burning the coal. Coal is burned, steam is generated, steam is used to drive the turbine. Turbine generates shaft power. The shaft is connected to a electrical generator, genset. Their electricity is generated, right? To rotate that generator, you need to drive this turbine. To drive the turbine, I need high pressure steam. How do I get high pressure steam? I get it by burning the coal, right? So how much coal I have to burn? If my 1000 megawatt plant, power plant I have, let us say, then every day I have to burn so much coal. Imagine, right? It will be tons and tons of coal you have to burn. Where do I get this coal? Coal is not available in Bangalore, right? Either it has to be imported from Indonesia, Malaysia, or Australia, or it has to be taken from a coal mines in Andhra Pradesh or the Tamil Nadu, or in nearest coal fields are Andhra Pradesh, Tamil Nadu, and what is that? Maharashtra. Then this Chhattisgarh, right, Orissa. Then further you can go like that. Huh? Jharkhand, West Bengal. I got the coal fields. You have to bring coal from there. How do you bring it? You have to bring it in a trains, railway wagons, right? One full wagon, right? Every day they consume a full one full load of one full train load of coal. So you have to schedule. I need so much coal to burn every day. Then we have to have a stockyard, because every day you cannot bring it from Nagpur or the Andhra Pradesh or Tamil Nadu. Every day coal will not supply. There is no just-in-time supply. Right? You have to make a sufficient buffer storage. 2 months, 1 month, 15 days storage they keep. Even if there is a transport disruption, there are no trains going around. Right? Trains are not available. What you will do? You'll shut down the power plant? No, you can't do that. Life is dependent on power. Right? So I have to book, I have to prepare, I have to pay for them. More money has to be paid, money has to be generated. Here I sell the electricity, make money. That money I use to buy the coal. Right? So this quantitative study, how much coal I have to buy every day, that comes from energy studies, right? Not just energy study, economics, everything you have to transport, everything you have to study. Okay, so that if I burn 1 kg of coal, how much energy I am able to generate? Out of that, how much energy I am able to convert it to the power? Right? This quantitative study is very essential. Not only that, you take simple example, your bike. Right? If I buy 1 liter petrol, how much I can drive? Can I go for 100 kilometers? Can I drive for 50 kilometers? Right? Can I go for 30 kilometers? It depends on the bike, kind of bike it is. Right? So that study. Suppose you want to plan, you want to go to, let's say, you are living in Puttur, you plan weekend trip. I want to go to Mangalore and come back, watch a movie. Then I have to plan now. Before going here, how much petrol I have to fill in my tank. Right? You have to so you will look at the indicator whether petrol is there sufficient. Okay, it is sufficient, no problem. I can go and come back. If it is less, go to petrol bunk, add fuel to your petrol fuel tank, and move. Suppose you plan to visit Bangalore and come back. Drive your car, go to Bangalore and come back. Then you have to plan before leaving Bangalore. You will decide: should I fill my tank? Already the tank is filled or not filled? Should I fill it or half fill it? I need 10 liters, 20 liters, 30 liters. Or okay, fine, I'll take some 20 liters now. On the way, I'll remaining fuel I can get. Right? Suppose I'm going in Ghat section, there is no petrol bunk. I should be well in advance prepared. Whenever I'm entering Ghat section, there is no petrol bunk. I will look at my indicator whether sufficient petrol is not there. Right? So like this, for our day-to-day life, energy study, quantitative study of energy is very, very essential. Okay? Let's go to next slide. This is the very basics that I touched upon. So what work is a what is work? Work is a one of the basic mode of energy transfer. What is work? Work is the one of the basic mode of energy transfer. There is a definition of work. So this is how you define the work in a mechanics. You have studied mechanics, right? Physics. What is definition of work? You want vector addition, vector manipulations you do, right? Work is a scalar quantity. But the work is a result of force, right? A force acting on mass causes work done, right? So how much work is done when a force acts on mass, right? So you say the work is done by a force as it acts upon a body moving in the direction of the force. You have a mass, some mass. Can you hear me? Hello? Hello?
Yes, sir.
Okay,
Yes,
there
sir.
was a network issue. I lost network. Okay, fine. So now you are able to hear. So work is said to be done if a force acting on a mass moves it in the direction of force. Only then we say work is done. Okay, work is the vector scalar product. right? Dot product we say. There is a force and there is the displacement. Both should be in the same direction. Only then we say work done. Otherwise, no work is done. Suppose you take this example: the moon is rotating around the Earth, or Earth is rotating around the sun. So there is a gravitational force of attraction that is acting on moon, right? And moon has got a mass, and it is moving. It is getting displaced. It's going around, right? Whenever moon takes one round around the Earth, it travels so many kilometers, so many lakhs of kilometers, right? So any work is done there, there is a force, gravitational force of attraction is acting on the moon. Therefore, he is in the Earth's gravitational field. Otherwise, the moon would have lost. Earth would have lost moon. There is a force of attraction that is holding it back, right? But any work is done there when that force is acting and the moon is moving, right? Displacement is there and the force is there. Both are there, right? Force and displacement, both you have. Do you say the work is done when Earth moves around the moon moves around Earth and the force of a gravitational force of attraction is acting on it? Is there any work done in that example? Can anybody give answer? Yes or no? You should say. Don't keep quiet. Am I audible to you? Can you hear me or not?
Yes, sir.
Any work is done when moon moves around Earth, right? He goes around Earth, right? Moon rotates around Earth, right? Revolves around Earth, right? Yes or no?
Yes, sir.
So any work is done, there is the gravitational force of attraction is acting on moon. Do you say any work is done or not? Anybody has to say. You say or you say
Yes,
you don't know. You don't know. Work is done or not done? Or you don't know?
Not done.
No,
Huh? Work
not
is
done.
Not done.
not done. Why work is not done? There is a force and there is a displacement.
Force
How do you
is
justify?
not
Huh?
not in the direction of movement.
Okay. Suppose if I give you force and the displacement, how do you find out what is the equation you use to find out work done? Force value I say so many newtons and the displacement so many meters. How will you find out the work done? Mechanics you have done, no? Work done. Equation you have studied it.
Force and displacement.
Work is equal to
Force
is it?
varies.
Force and displacement.
Force into displacement. Is it simple multiplication?
Force and displacement.
Huh?
Vector.
Huh? How do you multiply forces? What are different ways of multiplying forces? If I give you two forces, let us say A and B, how to multiply them? You simply multiply two forces A and B, or different ways are there?
Vector multiplication.
Huh? Vector
Multiplication.
vector multiplication, right?
Yes.
So work is a vector multiplication, or what kind of multiplication it is? Which kind of? There are vectors are multiplied. There are two types of two ways you can multiply. The products are two types. When you have two vectors, you want to multiply. You can multiply in different ways. What are the different ways of multiplying them? A and B. How do you multiply?
Scalar and
Vector and a scalar multiplication. Dot product or a cross product, right? A cross B or
Yes,
a
sir.
dot B. A dot B, right? So work is what kind of product it is? Is it a dot product or a cross product? F and a L, let us say displacement L, F is the force, two vectors are there. So if you want to multiply and find out work done, what is the kind of product you look at? Is it a cross product or a dot product? Work is what kind of product? Dot product or cross product? Please respond. At least you say you don't know. Don't keep quiet.
It is a vector product.
Vector product. Dot product. How many of you say, who says the dot product? Who says vector product? What is your name? Someone said dot product. What is your name? Tell me your
Alvin,
name,
sir.
man. I'll not. Alvin. Alvin said it is vector product, right? Somebody
sir.
said a dot. Somebody said dot product.
Vector
Who said
product.
dot?
Dot product makes sense, sir.
Who said dot product? Alvin.
Yes, sir.
Who's okay? Somebody said the vector product. Who is that?
Rakesh.
Rakesh. Rakesh said the vector
Vector
product, and Alvin vector product. Alvin says dot product. Now there is a dispute. Both are not agreeing. Who is correct now? Rakesh is correct or Alvin is correct? Prerna, can you say
Both
who is
are-
correct here? Both are correct.
Both are correct.
Both
Dot
are
and
correct.
Sir.
Huh? Can somebody has to say, not they. Someone else should comment on this. Tell your name and then say who is correct. Alvin is correct or the Rakesh is correct.
Vector product is correct, sir.
Vector product is right. Okay. Alvin, you want to say anything? Prerna and Rakesh both are saying it is vector product. You want to change your stand or you want to continue with the same statement? It's a dot product. What is your opinion on this? Alvin, can you hear me?
Sir,
You want to stick
Sir.
to original statement or you want to change your statement?
Dot. I'll
Huh?
stick to my change, sir. I'll change.
You want to change
Yes,
or
sir.
you want to stick? What do you want to say?
Change.
Work is a
Change.
vector product.
Yes, sir.
So all three, Prerna, Rakesh and Alvin, all are saying it's vector product. Correct? Am I right? Anybody
Yes,
else
sir.
want to comment? Anybody else wants to comment on this in the class? Rest others are passive, dormant members, sleeping partners. They are not interested in any discussion here, right? It seems. Others are alive or dead in the class. The total, how many students are there? 40, 47, right? Anybody wants to say anything?
Yes, sir.
Prerna, Alvin, Rakesh are saying work is a vector product. Anybody wants to say anything?
Dot product.
Who wants to say dot product? Who is that?
Prashant.
Prashant says dot product. Prerna, Rakesh, and Alvin are saying it is a vector product. But Prashant wants to say it is a dot product. Okay, fine. So anybody else?
Cross
Anybody wants to? See, the three people are saying. Sorry, anybody else wants to say anything?
Dot.
Dot product.
Dot.
Who is
Dot.
saying? Prashant said.
Sir.
Sorry,
Sir, it is a dot product.
who is that? What is your
Dot,
name?
sir.
Ashik.
Ashik says dot product. Prashant says dot product. Alvin said dot product, but he changed his mind. Right?
Dot, sir. Dot.
What is your name? What is your name? Your name?
Nitin.
Nitin. Okay, fine. So Nitin says, Prashant says, then says dot product.
Ashik.
Ashik says dot product. Other three are saying vector product. Anybody else wants to say anything?
Dot product.
Saying dot.
Dot product.
No, so many numbers. Who is this? Please tell your name.
Dot product.
Who is that? Who is that?
Dot product. Rajal play.
Rajan. Rajul is saying dot product. Okay, fine. So many numbers are coming up now. Many people are saying dot product. Dot product. So many people. Okay.
Dot product.
Okay. Alvin. Prerna and Rakesh, you want to change your stand or you want to stay back?
I will change, sir.
Huh?
I will change, sir. Dot, sir. It's dot.
Who is that?
Alvin, Alvin.
Olive, you are saying dot product. Okay, you came back. Initially you said the dot product. Then change your mind.
Yes, sir.
And now you are swinging back.
No, sir. Dot, sir.
Dot. Okay. So who is right here? Is it democracy? So
Dot
majority is
product.
right? Huh? Huh? Can we use a democratic? Majority is right. Huh? Scientific principles are not based on democracy. Okay? Even if majority says something wrong, as a scientist, you should have an independent view. Right? So if 10 people say wrong thing, you also say, okay, yes, come on, right. All are saying vector product, I will also say vector product. No, never. You should have an unbiased, independent opinion. Okay? Work is a dot product. Vector is a scalar multiplication, not vector multiplication. Okay? So when you want to multiply a dot product, AB, how you write? A, magnitude of A, into magnitude of B, into, how do you define scalar product? Dot product? What is the equation for the dot product?
Two force vectors are multiplied.
What is the equation I want? A and B, two vectors are there. You want to find out the dot product.
AB cos theta.
What is A? A is magnitude of the vector. B is magnitude of another vector. Cos theta. Theta is what? What is theta?
Angle between A and B.
Angle between two vectors. Right?
Two vector.
Angle between two vectors is theta. Cosine of that angle. Right? Cos theta. Cosine of that angle. So magnitude of vector A, magnitude of vector B multiplied by cosine of the angle between two vectors gives you the dot product of two vectors, and it is a scalar quantity. Vector is work is a scalar quantity. So when you take two vectors, their product, their interaction result can be a scalar or vector. The resultant can be a scalar or vector. In case of force, it is a scalar quantity. It is not vector. Work is not a vector. It's a scalar. Okay, dot product is a scalar quantity. Vector product is another vector again. Okay, so like that, it is there. This is a mechanics definition of a. In thermodynamics, we have an entirely different definition for the work that we will see in the next class. If you find some time, in Google, you can search what is the mechanics definition of a work. Just to go through that, find out. Next class, come prepared so that the discussion will be more healthy. Okay. For time being, we'll stop now. I will download your attendance and then I will leave. Okay. So if you are